In this tutorial, you'll learn about specific characteristics of quadratic functions and points along their parabolas. So let's get started. For this lesson, you'll be able to determine the y-intercept, the vertex point, the axis of symmetry from a graph, or from an equation. You're going to be able to identify these particular vocabulary words from the graph or by using your TI-84 calculator. We'll also show you the appropriate formulas to calculate things such as the vertex points. All right, let's get started with some basics. A parabola is a U-shaped graph where the lowest or highest point is called the vertex. In the middle of the vertex, you can draw an imaginary line called the axis of symmetry, at which points the left side and the right side would be symmetrical. Here are some visual representations of the three vocabulary words we'll be focusing on today. The vertex point, which is the turning point of a parabola, can either be a low point or a high point. The difference between them, even though they're both called vertex, is that one is referenced as a minimum value and one is referenced as a maximum value. So you either have a minimum or a maximum. The second word is the y-intercept, which is strictly where the graph crosses the y-axis. And then the third is an imaginary line drawn through the middle of your vertex point that creates the axis of symmetry. Let's get started with the easiest one first, identifying the y-intercept from a graph. All you have to do is find the point where the graph crosses the y-axis. Fairly simple. So if you take a look at this graph here, the parabola crosses the y-axis at the point 7. Therefore, the y-intercept is the point 0, 7. Now, if you give an equation, it's actually simpler, but it doesn't seem as such. In an equation, as long as it is written in standard form, that's ax squared plus bx plus c, all you have to do is identify the constant value. Whatever that constant value is, that's your y-intercept. So for us, in this equation, the constant value is 8. Therefore, the y-intercept is the point 0, 8. If it's not in standard form, you simply rearrange the equation by using an inverse property, move that constant over to the left-hand side, and there's your y-intercept. Oftentimes, you would need a y-intercept so that you can understand what the initial value is in a word problem. So the next characteristic we're going to study is the direction of your parabola. So a parabola can face in two different ways, and that would be upwards facing or downwards facing. So we already know what the c value tells us, right? Y-intercept. But now we're going to talk about what the a value tells us, or the first number in the standard form. The direction of the parabola, whether it's facing upwards or downwards, can tell you lots of things. It can tell you if it has a vertex that is a minimum or a maximum, a high point or a low point. And when you're looking at the parabola, it's very easy to tell. But if you're looking at an equation, it takes a little bit more thought. But it's just as simple. If you can find the a value, then you can tell if it's upwards facing or downwards facing. If your a value is positive, it faces upwards. If your a value is negative, it faces downwards. It's that simple. This is known as a reflection when you put that negative sign. It flips your u upside down. So since this equation has a positive a value, this is an upwards facing parabola that just happens to cross through the y-axis at -7. Remember, look only at the a value when trying to determine if you have an upwards or downwards facing parabola. Once you determine whether it's up or down, you'll be able to tell me whether it has a min or a max. If you're facing upwards, you have a low point, so you have a minimum. If you're facing downwards, you have a high point, known as a maximum. So for us, positive 2 is an upwards facing parabola with a minimum. How about this one? Is it facing upwards or downwards? Upwards. Does it have a minimum or a maximum? It has a minimum, right? An upwards facing parabola has a low point. How about this one? Is it facing upwards or downwards? That's facing downwards. Has a high point, so it has a maximum. How about this one? As soon as you see a negative side, that's a downwards facing parabola. Since it has a high point, it has a maximum. What about this last one here? Do you notice anything out here? Me neither. So that's an upwards facing parabola with a minimum. Now if there had been a negative sign out here, that would be downwards facing. Alright, I think it's time for you to give it a try on your own. Pause the video now. Alright, did you take a moment to write down your answers? Upwards or downwards? Min or max? Here's the solutions. Hopefully you got them all right. Alright, let's talk about this vertex point just a little bit more. A vertex is an actual specific point along the parabola, and it has an ordered pair value. In this particular example, the vertex point is located here. And if you look at the coordinates, you can identify that value, 3, -4. That is the specific vertex point, and that's how you identify it from a graph. You simply look for the lowest or highest turning point. The second thing is, in the middle of your vertex is your axis of symmetry. And if you can find the vertex, then you can find the axis of symmetry. Because all you need to know is that the axis of symmetry is the same as the x value. It is an imaginary vertical line that passes through this x point. So therefore, it has the equation of x equals the axis of symmetry is always an x equals equation because it is always a vertical line. So the axis of symmetry for this particular graph is x equals 3 because the vertex x point is 3. So find the vertex, then you can find your axis of symmetry, also known as an a.o.s. All right, let's see if we can't practice this a little. Identify the vertex point, and then tell me the axis of symmetry. Pause the video now. All right, let's see how you did. The vertex point for number 1 was 2, -1. And the axis of symmetry always goes through that x value. So if the x value is 2, the axis of symmetry is x equals 2. For question number 2, the vertex was 1, 4. So the axis of symmetry goes through the x value, so it's x equals 1. All right, what if we didn't have a picture? How would we find the vertex then? Well, there's an easy way and there's a hard way. The easy way is to use your graphing calculator. So in order to do that, you'd have to enter this equation into the y equals button, and then you'd have to use the second trace feature, and you would choose either number 3 or number 4. You'd carefully choose depending on if you knew if the parabola was upwards facing or downwards facing. Once you select minimum or maximum, it's going to ask you to press enter for left bound and right bound, which we practiced when we found the roots of a quadratic. If you don't remember, why don't we take a look at our calculator now? So I've entered into my y=, button our equation of our quadratic, x squared plus 2x minus 4. I'm going to press the calc feature, which is second trace. And this one is an upwards facing parabola, so I know it has a minimum. So I'm going to choose number 3. And once my graph is drawn, it's going to ask me if I am left bound. It's going to ask me if I am to the left of my vertex point. And so I'm going to move my cursor over, then I'm going to press enter. Now it's asking me if I'm right bound, so I'm going to move my cursor over and press enter. And my two imaginary vertical lines here should have the vertex in between, which it does. So I'm ready to make a guess, so I'll press enter. And it looks like -1, -5 is my vertex. -1, -5 is my vertex. And that's how you use your graphing calculator. Now let's say you're asked to find the vertex algebraically, which means you can't use your calculator. Well, this is how you would do it. You would use the formula -b/2a. That's it. If you can identify the b value and the a value, then you can find the x value of your vertex. Now the y value, that requires a bit more work. So let me show you what I mean. I'm going to move these over here. And I'm going to start by first identifying my a, my b, and my c values. So for my x value, I have -b/2a. b is 2, and a is 1. So it looks like my x coordinate of my vertex is -2/2 or -1. So that is half of my final answer. Now, how do you find y? Well, you take this equation and you find y by substituting in numbers for x. So I'm going to remove all of the x's and replace them with their x value. So I'm going to put a -1 into both of these locations, and I'm going to compute. -1 squared is 1. 2 times -1 is -2. And then -4. So 1 minus 2 is -1. -1 minus 4 is -5. And that's how I get my same vertex for the equation we did on the previous screen, right? -1, -5. That's how I get my vertex algebraically. This takes a little bit of practice, so why don't we try a couple? Remember, the formula is -b/2a. Then you have to substitute in to find y. If you want to try it on your own, pause the video now. Otherwise, I'll work through this equation one more time, and then you can try one on your own. Identify your a value, identify your b value. Plug those into your vertex formula. So -b/2a. b is -12, a is -2. Simplify. All right, I've got my first value. Now, I need to substitute. Remember, you remove all of the x's and replace them with parentheses. Then enter your x value. Now this one's kind of long and there's no reason for me to do it in my head, so I'm going to pick up my calculator because that's a smart decision. And I'm simply going to enter this exact sentence with all of its parentheses and all of its powers and negative signs, and I'm going to get it correct because the calculator is going to compute it for me. Don't forget to use negative signs instead of subtraction signs when necessary. So it looks like my y value is going to be 24. -3, 24. Now, here's the thing. You might be asked to find the vertex algebraically, but you can always use your calculator to check. I'm simply going to type this equation into my y= button. Right? So let's see. I've got -2x² minus 12x plus 6. Oops, I forgot my x. Now, it seems like my answer is going to be way up, or negative 324. So I'm probably not going to be able to see it on my graph here. Yep, see how it goes off the screen? So here's what I'm going to do. I'm going to change my window. That means what I'm looking at. I'm going to change my window so that instead of going all the way up to 10 on the y-axis, I'm going to make it go up to 30. Now let's take a look. Now I can see the top. So I'm going to do the same thing I did last time, which is I'm going to calculate the vertex by pressing second, calc. My vertex happens to be a maximum, so I'm going to choose number 4. Move my cursor over so that it is left bound. So click, 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 enter. Move my cursor so it's right bound. Click, 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 and enter. And negative 2.999, yep, that's a negative 3. Negative 3, 24. Now, see how my x-axis, the lines have changed a bit? That's because I zoomed it out. Now for my next problem, I may not need it so zoomed out. Maybe I want it back to a 10 by 10 grid. The fastest way to do that is press zoom, standard, number 6. And that will automatically bring you back to the 10 by 10 grid. All right, so that's how you calculate a vertex algebraically by hand and how to double check it on your calculator. Ready to try one on your own? Pause the video, give this a try. All right, let's see how you did. I solved it algebraically, and you could also check it on your calculator. So these are the 3 things you learned about today. How to identify the y-intercept from the graph or the equation. How to identify the line of symmetry. And how to identify the vertex point. You can identify these 3 things from an actual graph, but you can also determine it from the equation, right? The vertex point can be determined as a min or max by looking at that a value and using this particular vertex formula. The axis of symmetry can be found after you start your vertex formula and simply taking the x value and writing it into this equation. And the y-intercept is just sitting at the end of the sentence. Now that we've concluded the lesson, it's expected that if you were given an equation, you could determine all 4 of these identifying characteristics. That you can tell me that this has a maximum because it's a downward-facing parabola. That you could actually tell me the vertex point. That you could actually give me the equation of the axis of symmetry. And that you know that the y-intercept is 3. So this example has been provided in the notes posted in the Google Classroom. So you can refer back to this as you're working on some of your examples. Here's an example of a question you might be asked. You'd be given a graph, you'd be given an equation, and you might be asked some of these other things that we haven't done in a while, like what is the domain, or what is the range? And then the items we covered today. What is the vertex, the minimum, maximum, the axis of symmetry, and the y-intercept? If you'd like, you could pause the video now and give this a try. I'm going to show you the solutions now. First, why not draw your graph? Go to your calculator, enter this into the y equals button, make a table of points, and create your parabola. Once you see that parabola, you can identify the domain, which would be all real values. You can identify the range, which would be all y values greater than or equal to 2. And you can identify the vertex point just by looking. And you can identify the axis of symmetry because you looked at the vertex. And you could identify the y-intercept. So this is the only one that I want to talk about really quick. When you have a vertex point, say 1, 2, when I ask you what is the min or max, I'm specifically asking how high or low it goes. So I'd be referring only to the y value. A vertex represents the location of the turning point, not the value of the minimum or the maximum. So the minimum or maximum, although is located in the point of the vertex, the value we're looking for is just the y value. So keep that in mind if you're asked that question. All right, if you'd like to give some a try on your own, you can try these. You don't necessarily have to graph them, but can you determine the vertex and the axis of symmetry algebraically? Maybe try 2 algebraically and maybe try 2 on your calculator. Pause the video and give it a try. All right, let's take a look at your answers. You should pause the video here if you want to check over your work. Here are the first 2, and here are the second 2. All right, that concludes our video on characteristics of quadratic functions.